Albert Einstein is one of the most well-known and highly influential scientists in history. His contributions to the field of physics are numerous and diverse, but he is perhaps most famous for his contributions to the development of quantum theory. Quantum theory is a fundamental theory in physics that describes the behavior of matter and energy at the atomic and subatomic level. It is based on the idea that energy is quantized, meaning it exists in discrete packets or quanta, rather than being a continuous entity, as was previously believed. This revolutionary idea was first proposed by Max Planck in 1900, but it was Einstein who provided the first experimental evidence for the quantization of energy in 1905 through his theory of the photoelectric effect. In this theory, Einstein proposed that light could be described as a stream of particles, which he called photons. He used this idea to explain the phenomenon of the photoelectric effect, in which electrons are emitted from a metal surface when it is illuminated with light. Einstein's theory successfully explained this phenomenon, which had previously been a mystery, and it was a key step in the development of quantum theory. Einstein's contributions to quantum theory didn't stop there. In 1911, he published a paper on the theory of specific heats, in which he used the concept of quantized energy to explain the behavior of solids at low temperatures. In 1913, he published a paper on the theory of the Brownian motion, which described the random motion of particles suspended in a fluid. This work provided further evidence for the existence of atoms and molecules, which are the fundamental building blocks of matter. In addition to these contributions, Einstein is also known for his work on the theory of relativity, which he published in 1905 and 1915. This theory, which describes the relationships between space, time, and mass, was also a major milestone in the development of quantum theory. It provided a new framework for understanding the behavior of matter and energy at the atomic and subatomic level, and it remains an important part of modern physics to this day. In summary, Albert Einstein made numerous and diverse contributions to the field of physics, but he is perhaps most famous for his contributions to the development of quantum theory. His work on the photoelectric effect, specific heats, Brownian motion, and the theory of relativity all played a significant role in the development of this revolutionary theory, which has had a profound impact on our understanding of the world around us. Niels Bohr was a Danish physicist who made significant contributions to the development of quantum theory, a fundamental theory in physics that describes the behavior of matter and energy at the atomic and subatomic level. Bohr's work helped to bridge the gap between classical physics, which describes the behavior of macroscopic objects, and quantum mechanics, which describes the behavior of microscopic particles. One of Bohr's most significant contributions to quantum theory was his development of the Bohr model of the atom. This model, which was published in 1913, was an early attempt to explain the behavior of atoms using quantum theory. In the Bohr model, an atom is composed of a central nucleus surrounded by a cloud of electrons. The electrons are arranged in shells around the nucleus, and each shell can hold a specific number of electrons. The Bohr model was able to explain the emission spectra of atoms, which are the lines that appear in the spectrum of light when an atom absorbs or emits energy. It also provided a framework for understanding the behavior of atoms in chemical reactions. However, the Bohr model had several limitations, and it was later revised and expanded upon by other physicists. One of these physicists was Wolfgang Pauli, who developed the Pauli exclusion principle, which states that no two electrons in an atom can have the same set of quantum numbers. This principle helped to explain why atoms have a specific number of electrons in each shell, and it played a crucial role in the development of quantum mechanics. Bohr also made important contributions to the development of the theory of quantum electrodynamics, QED, which describes the behavior of particles and fields in the presence of electromagnetic forces. Bohr's work on QED helped to establish the concept of renormalization, which allows physicists to make precise calculations of the behavior of particles even when the calculations involve infinities. In addition to his contributions to quantum theory, Bohr also made important contributions to the development of nuclear energy. During World War II, he worked on the development of the atomic bomb as part of the Manhattan Project. After the war, he became an advocate for the peaceful use of nuclear energy and the establishment of international controls on the development and use of nuclear weapons.